All right, let's go for something brand new. All right, so before we do, let's just solve a couple of these things. So we're solving for x. So on 2x equals 6, to solve for x, we're going to divide by 2. So then x equals 3. Easy enough. All right, on the next one, 2 over x equals 6. I need to first get rid of the x. So now 2 equals 6x, and then I divide by 6. So 1/3 equals x. Easy enough. X squared equals 6. I can square root both sides, so the square root squared cancels, so x equals the square root of 6, plus or minus, of course. Alright, so what about this last one? This last one we have 2 to the x equals 6. So some of the suggestions I usually get is we could x root it. And that's all good and great. The x root and the x cancel, so now 2 equals x root of 6. But our goal, when we solve for x, our goal is to have x equals, not root x of 6. So that one didn't work. And basically, if we were in class, I would have you sit here and holler out all kinds of things. You'd say stuff like divide by x, and so then we divide by x, but that didn't do anything because the x didn't cancel out. There's just really nothing you can do at this point. So what happens is we really need to learn how to get that x out of the exponent. And that's why we learn what we call logarithmic functions, is so that we can get x out of the exponent. So with a logarithmic function, what happens is, if you have 2 to the x equals 6, when we put it in log form, you're going to see the word log, and then you see this little guy down at the bottom, that's our base. So the base of our logarithm is 2, because the base of my exponent was 2. Those are the same number. We took the 2 and we put it there. And then a logarithm always equals the exponent. So if your exponent was x, your logarithmic equals x. And this 6 right here, it's not log times 6. This is actually log base 2 of 6. This is a part of log. Okay, imagine that you have a Tootsie Pop, and you have that, let's even see if I can get the color here. It's being difficult. Okay, anyway, we'll go with black. Okay, you've got that Tootsie Pop in the middle. Well, the Tootsie Pop in the middle is the 6. The 6 is on the inside of the logarithm, and then this outside candy part is the log. Okay, so the log is containing the 6. The 6 is inside the logarithm. We can't get it out of there. Okay, so you can't divide by 6 or anything like that. It's inside the logarithm. It's a part of the logarithm. Okay, so that is kind of the basics of logarithms. Let's go to the next slide. So when we look at this, this is the actual basics of a logarithm. If you have a base to an exponent equal to y, then you can rewrite that so that the base is the base of the logarithm, the exponent is what it equals, and over here the y is part of the logarithm. And so the way we say this is log base b of y equals x. And then we can go the other way too. If the base of the logarithm is b, the base of the exponent is b. If it equals x, that means that's going to be your exponent. And then the inside here is what the whole exponential thing equals. So let's practice this a little bit. If I look at this next part, here, this is in logarithmic form, and so I need to change it into exponential. So as I look at this, the base of my logarithm is 2. So that means I put a 2 as the base of the exponent. It equals 5. This logarithm equals 5. That means my exponent is going to be 5. So it'll be 2 to the 5th equals, and then remember what's inside the logarithm is what my exponential equals, 32. And think about that. 2 to the 5th equals 32. That's a true statement. Okay, let's go to the next one. The base of my logarithm is 5, so the base of my exponent is 5. It equals 0. That means my exponent is 0. And then inside of the logarithm is 1, so my exponential equals 1. And 5 to the 0 does equal 1, so it works out. Now the next one, we're going the other way, so we're given exponential. So let's see here. The base of my exponent is 10, so we're going to write log base 10 equals the exponent of 1, and inside the logarithm is what it equaled over here, so it's going to be 10. So we've got log base 10 of 10 equals 1. Now I'm going to be really picky about this, you guys. When I say log base 10 of 10, so log base 10 of 10 equals 1, I'm going to expect you guys to be able to say that correctly. Let's try it again. Log base 10 of 10 equals 1. Up here I've got log base 5 of 1 equals 0. Log base 2 of 32 equals 5. So let's try this next one. 2 to the third equals 8. So the base of my logarithm is going to be 2, since the base of my exponent was 2. It's going to equal 3. Remember, logarithms always equal the exponent. And inside the logarithm is going to be 8, because it equaled 8 over here. Okay, the next one I have to put it into exponential form. So the base of my logarithm is 10, so the base of my exponent is 10. It equals negative 1, so my exponent is negative 1. And then that will equal 0.1. So if you think about 10 to the negative 1, that's 1 over 10. And 1 over 10 is a decimal is 0.1, so that makes sense. And then this last one, log base 1/2 of 2 equals negative 1. Would be an exponent, or in logarithmic form. So, some special values, some things that we can point out and note. No matter what, if your base is b, it doesn't matter what you have here. You can have 10, you could have 15, you could have 1.5. It doesn't matter. But if you have base b of 1, it will always equal 0. Always. Base b of 1 equals 0. And that's because, let me turn that back into exponential. The base of log is b, so the base of the exponent is b. The logarithm equals 0, so my exponent is 0. Equals, and then inside the logarithm is 1, so my exponential equals 1. Now look at this. Think about it. B to the 0, anything to the 0 power is 1. That's true. That's why this doesn't matter what the base is. If this is a 1, this is a 0. Another one here is log base b of b equals 1. So notice if the base and the number here are the same. So the base of my logarithm and the number here are the same, then it's going to equal 1. And that is because if I rewrite in exponential form, b, that comes from this base, to the exponent of 1, equals what's inside the logarithm b. And yeah, that makes sense. B to the first power equals b. That's just simple exponential notation. Alright, so let's look at this. Basically now what's going to happen is without a calculator, we're going to be asked to solve these. Sorry, I know it's kind of fuzzy. We're going to be asked to solve these without a calculator. So log base 3 of 81. You can't really use a calculator anyway, so I'm not even worried about you cheating. Calculators don't work. So log base 3 of 81. We're supposed to figure out what that equals. This is going to equal 4. But let me show you how I know that. Instead of making it equal to a number, because I don't know what it equals, I'm going to make it equal to x. And then I'm going to rewrite it into exponential. So that would be 3 to the x equals 81. So now I'm looking at this thing saying 3 to what power equals 81? 3 to what power? Well, 3 to the second is 9, 3 to the third is 27, and 3 to the fourth is 81. So this equals 4, because that equals 4. Let's try the next one. Okay, log base 1/2 of 8 equals x. We'll make it equal to x. We'll rewrite it. 1/2 to the x power equals 8. Now if you think about it, 2 to the third power equals 8, correct? So I have 1/2 to what power equals 8? Well, it's going to be still a 3, but it's going to be a negative 3. That way it'll flip that 1/2 over to become a positive 2 to the third equals 8. So x is going to equal negative 3. Okay, the next one equals x. So 5 to what power equals 0.04. Now to help us out, let's write 0.04 as 4 over 100. So we'll put it in fraction form, 4 over 100. That still can be simplified, right? 4 over 100 is the same thing as, same thing as 1 over 25, right? So now I have 5 to the x equals 1 over 25. Well, 5 squared equals 25. So if I want 1 over 25, I'm going to need that 2 to be a negative. So x equals negative 2. Alright, log base 9 of 3 equals x. So we've got 9 to the x equals 3. I'm pretty sure the square root of 9 equals 3. And the way we do a square root with an exponent is 1/2. Okay, just a couple more. Log base 4 of 64. So that equals x. 4 to what power equals 64? Let's see, 4 squared is 16. 4 cubed is 64, so we've got a 3 here. Alright, make that equal to x. So 2 to the x equals 0.125. Once again, let's put that over 1,000 this time, right? So we got 125 over 1,000. And that can be simplified for sure. By what? I don't have my calculator, so I'm going to have to do this the old-fashioned way. 25 goes into 125 5 times, and 25 goes into 1,000 40 times, and 5 goes into 5 once, and 5 goes into 48 times. So 2 to the x equals 1/8. Well, 2 to the third equals 8, so I need to flip that over, so I'm going for -3 as my exponent. Alright, this one equals x, so I've got 1/4 to the x equals 256. Let's see here. 4 to the 4th power equals 256. But I have 1/4 equals 256. So I'm going to need a -4 to flip that 1/4 over. So x must equal -4 then. And let's see, one last one here. Log base 32 of 2 equals x. So 32 to the x power equals 2. So it looks like I'm rooting it. Now I know that 2 to the 5th power equals 32. So if I'm going the other way, 32 what power equals 2, I'm going to need the 5th root, which is 1/5. Alright, that is it. You guys will get your homework assignment tomorrow. Good luck.